Hello class, welcome to the next lesson in 8th grade Eureka Math. We're working in Module 4 and this is Lesson 2. Lesson 2 is about linear and nonlinear expressions. And there are 3 vocabulary words just in the title of the lesson. Linear, nonlinear, and expressions. And all of them are on the vocabulary list that you can see in front of you right now. Hopefully you have already started copying down the notes, copying down the vocabulary so that you are ready to discuss it and hear it. But because this is a video lesson, if you need a little bit of extra time to copy down the vocabulary, you can pause the video whenever you want to start copying the vocabulary and the definitions. Or you can go back at the very end of the lesson and write down the vocabulary and the definitions. Or you can print a copy of my notes that's on the Google Classroom, whatever works for you. I just really want you to think about how you can learn this vocabulary and these math skills as best as you can. Whatever works for you works for me. So today we're going to do a little kind of similar to what we did in Lesson 1. We're going to translate English into math. But we're going to be doing expressions, and then when we're done, we're going to have to decide linear or nonlinear. So you need pages 9 through 17 of your Module 4 workbooks. You'll need a page for notes that hopefully you are already filling out. You'll need things to write with. Maybe you want to use colored pencils or different colored pens to help be more organized. Whatever you want to do works for me. But let's talk about these vocabulary terms. A lot of them are connected to expressions. And there now you can see all of the vocabulary. Those are I think there's 7 vocabulary words today, 7 vocabulary terms today. So I know it's a lot of writing. That's why it's okay if you pause the video and finish later. It's why you can come back and look at it again when it's all done. Or you can look at my notes on the Google Classroom. Our first vocabulary term is coefficient. A coefficient is a number that multiplies a variable. So, for example, if we have 3x, 3 is the coefficient because 3 is multiplied by the variable x. So when you see 3x, x is the variable and 3 is the coefficient. That's our little example. For the next vocabulary word, constant. A constant is an amount that does not change. Now remember, a variable can change. A variable is unknown and it can change. But a constant does not change. An example of a constant is like 7. 7 is a constant. 7 will always be 7. 7 does not change. It is 7. It is not 6. It is not 8. It is 7. It is constant. It does not change. The next vocabulary term is equation. It's a mathematical statement with an equal sign. Now, this is a vocabulary word we used in Lesson 1. We're going to talk about equations again. An example of an equation is like 2 plus 3 equals 5. It is a math statement, and it has an equal sign. So that is an equation. Now, similar to an equation is an expression. An expression is one or more terms without an equal sign. So it's a math statement with no equal sign. So, for example, it's like 5 plus x. That is an expression. There is no equal sign. Or you can say 4 plus 5. If you just write down 4 plus 5 and you do not write equals 9, 4 plus 5 by itself is an expression. Or you can even say like x. X all by itself is an expression because there is no equal sign. It's a math statement with no equal sign. So that's the difference between equation and expression. Equation has 2 expressions. 2 plus 3 is an expression, and 5 is an expression. So an equation is 2 expressions that are equal. An expression is just one statement by itself, no equals. So equation is two expressions that are equal. An expression is just a statement with no equal sign. Our next two terms are similar also, linear and nonlinear. A linear means it's a straight line. In fact, you can even know that linear means a straight line because the word line is in linear. Linear means a straight line. And we know if it's, well, it's a straight line when we graph it. But when we write the equation for the lines, because every line has an equation that we can graph, the equations, linear equations, have only 0 and 1 for variable exponents. Only 0 and 1 for variable exponents. So like x to the 0 or x to the 1 only. Only x to the 0 or x to the 1, nothing else. If you see anything else in the exponent, if you see a 2, a 3, a 4, or a fraction or a negative, it is nonlinear. So linear has only zeros and ones for variable exponents, and when you graph them, linear equations make straight lines. Nonlinear, when you graph them, are not straight lines. They are curved. So these are not straight lines. Nonlinear means not lines. Nonlinear, not lines. And you can tell just by looking at an equation if it makes a curved line, because it does not have, it has something else other than 0 or 1 for variable exponents. So you can see like x squared. X squared means nonlinear. X cubed means nonlinear because 3 is not 0 or 1. X to the negative 1 is nonlinear because linear means only 0 and 1. If there's x to a fraction, that's nonlinear. X to the 1/2 is nonlinear. Any exponent that is not 0 or 1 makes a nonlinear graph, a nonlinear equation. And nonlinear means it does not make a straight line. Our last vocabulary term for this lesson is term. Term in math, term is a vocabulary term, but in math, term means that it's something is part of an expression. So any part of an expression is a term. Like a number is in an expression is a term. A variable in an expression is a term. Or a combination is a term. So for example, if we have like 2 plus x plus 3y, that is an expression with 3 terms. We have 3 terms. 1, 2, 3 terms. This makes 3 terms. 2 is a term, x is a term, and 3y is a term. 3 terms. A number can be a term, a variable can be a term, or a combination number and variable can be a term. So that is the mathematical definition of term. So 7 vocabulary words. We'll refer back to them today. We'll look at them. We'll talk about them. It's important to know when we're talking about equations. All of these words are important when we're talking about equations. And so we're talking about equations in Module 4. So we're going to introduce these terms, these words, super early because you will see them all the time during Module 4. A couple of them we'll focus on specially today. We're going to focus on 3 of these today: expression, linear, and nonlinear. These are probably the 3 most important ones today, but you might see the other ones today also. So today, we're going to be doing what we did in lesson 1. We will be translating English sentences into math expressions. This is similar to lesson 1. If you remember lesson 1 was making math equations. Today, we're just going to worry about making math expressions, translating English into expressions. So no equal signs today, but it's similar to lesson 1. Then after we translate, so the first thing we're going to do is translate. Then after we translate, we will decide if those expressions graph to linear or nonlinear lines. So we're going to say, are those expressions linear or nonlinear? And I did draw some examples right here. Linear expressions can look like these. These are some examples of linear. And these, the pink are examples of linear. The brown are examples of nonlinear. Now, it's easy to see if you graph something if it's linear or nonlinear. But today we're going to decide linear or nonlinear without graphing, just looking at the equations, just looking at the expressions. When we look at an expression, do we know if it's linear or nonlinear? And we're going to we're going to make some expressions, and we're going to use our definitions of linear and nonlinear to decide. So right now, let's take a little bit of a pause. You can pause the video, and you can finish any notes or any of the vocabulary definitions that you did not finish. Go back in the video, look at them again, and finish anything you need to finish. And then whenever you're ready, we will do some of the exercises together to practice just determining linear or nonlinear. Okay, welcome back. Hopefully you took some time to finish up your notes and or take a little bit of a water break and you are ready to work. So let's go to page 9 of our workbook and the exercise that we're going to do to practice. So for all the problems, there are 12 exercises that we're going to do. Let's work on them a little bit together. Let's see the directions first. It says, write each of the following statements in exercise 1 through 12 as a mathematical expression. That means translate. We're going to translate. And then state whether each expression is linear or nonlinear. If it is nonlinear, then explain why. Okay, let's get going. Let's have some fun with this. Oops, moved my camera. Let me fix that. Looks good. Okay. So number 1 says the sum of a number and 4 times the number. Well, just like in lesson 1, the first thing we do is tell what our variable is going to be. I'm going to say x is the number. So instead of number, I'm going to put x. So the sum of x and 4 times x. So there we go. And now it says the sum, which tells me I'm going to be adding. So I need to add x and 4 times x. 4 times means 4 times. So I'm adding x and 4 times x. So I'm just going to be doing x plus 4x. That's my expression. It's the sum of x and 4 times x. X plus 4x. So that's the first part. Easy enough. Now I need to decide, is this linear or nonlinear? Well, remember the definition of linear means the variable exponents can only be 0 or 1. 0 and 1 only for variable exponents. So let's look at number 1 and see what our exponents are in the variables. Now, some people might be saying, well, Mr. Bear, these don't have anything. There is no exponent. So what do? Well, you have to remember all the way back to Module 1. When we did Module 1, we learned that if you don't see an exponent, it's still there. It's shorter not to write, because remember, x with no exponent is really just x to the first. It's really just a 1 there. It's just mathematicians decided that we don't have to write the 1 because we'll all just remember that it's really there. So this x has an exponent of 1. This x has an exponent of 1. It's the 1 is there. It just takes extra time and ink to write, so it's just easier if everyone just agrees we know the exponent is 1, so we don't have to write it. So now the variable exponent is 1 for both of them, which means, going back to our definition, only 0 and 1. Well, I only have 1s, so this is linear. It's a linear expression because the variable, I only see an exponent of 1 with the variable. Let's look at number 2. Number 2 says the product of 5 and a number. The product of 5 and a number. So if we have x, our variable is going to be the number because that is unknown. So I'm going to say cross out a number, and I'm going to say that's going to be our variable x. So the product of 5 and x. Well, product means I'm going to multiply. I'm going to write multiply so that anybody watching is not confused because I have x over here also. So I need to multiply 5 and x. Well, that's just 5x. Done. 5x is 5 times x, the product of 5 and x. And to know if it's linear or nonlinear, I have to look at the exponent of the variable. Well, this is the variable, and the exponent is missing, which means it's just like in number 1. It's just an invisible 1. So this is linear because the variable is 1. The variable's exponent is 1. Let's look at number 3. Number 3, we're getting a little bit more complicated. It says multiply 6 and the reciprocal of the quotient of a number and 7. Multiply 6 and the reciprocal of the quotient of a number and 7. So this is going to be a little bit tricky, but still, let's all start with x is going to be the number. So right here, a number is going to be crossed out. I'm going to put my variable. 7 is going to be that. Quotient means to divide. Multiply 6 means multiply by 6. Now, the reciprocal might be a little bit tricky for you. You might not remember what the reciprocal means from Module 1. Reciprocal from Module 1, remember, we take something, and to do the reciprocal, it's to the negative first exponent. -1 exponent. That's what the reciprocal means. Reciprocal means it's to the negative first power. So let's put all this together. And to start, I always like to start when I'm translating these, start with the variable. So I do the variable first. So the variable says quotient of x and 7. So I need to divide x and 7. So I'm going to do x divided by 7. And now, because I did this part, I'm going to move closest to this. So it says, so I did this part, so let me move, start over here and walk the other way. It says the reciprocal of the quotient. So I need to do the reciprocal of the division. So I did the quotient, I divided x and 7. Now I need to do the reciprocal of the division. So that means, remember, reciprocal means to the negative first, just like that. So I take the division, I put the whole division in parentheses, and that's to the negative first. And that's the reciprocal of the division. Last part, moving all the way to the other side, says multiply 6 and the reciprocal. So I do the reciprocal times 6. So I did multiply 6 and the reciprocal of the division with x and 7. That is my expression right there. Part 2, I need to decide if this is linear or nonlinear. Well, remember, linear's definition was variables can only be 0 and 1. Variables are only allowed to be 0 and 1, and that's a positive 1. This is a negative 1. And if you remember back to Module 1, negative 1 goes to everything inside. So when I pass this in, I'm going to get x to the negative 1 on top of 7 to the negative 1 times 6. So now I have an x with a negative 1. That means it's nonlinear. Because remember, only zeros and ones are allowed to be connected to variables. This variable has a negative 1. It does not fit our definition of linear, so it is nonlinear. Look, even in my examples for nonlinear, I said x to the negative 1 is an example of nonlinear. X to the negative 1 means nonlinear. Moving on to number 4. Number 4 says twice a number subtracted from 4 times a number added to 15. Okay, so x again is going to be my number. X is the number. So every time I see the number, I'm going to put a variable. So twice x subtracted from 4 times x added to 15. Now twice, you should know, means 2 times. So 2 times x subtracted from 4 times x. So I have 2 times x, twice x, subtracted from 4 times x, added to 15. Now, so we have 2x because that's twice x. Now this says subtracted from 4 times x, 4x. Now a lot of people might put 2x minus 4x. That is not correct. Think about how the sentence works. It says this comes from this. So if you come from somewhere, where you come from is where you start. So we come from 4x, which means that's where we're from, where we start. So we start with 4x, and 2x is subtracted. It comes from the 4x. So we do 4x minus 2x, not the other way around. Subtraction is very important to remember what order you do things in. If you do them in the wrong order, subtraction is going to be very, very wrong. But this is the correct order because the 2x is coming away from the 4x. So this is what we do first. That's the first part of the sentence. And then this says added to 15. So we do this, all of this added to 15. And that is how we write that expression. And we decide if this is next part we decide if this is linear or nonlinear. And this expression is linear because the variables only have ones. Remember, x by itself is just x to the first. X by itself is x to the first. We don't need to worry about being nonlinear. There's only x to the first. Next thing we're going to work on, number 5. Moving on to number 5. Number 5 says the square of the sum of 6 and a number. So x again is going to be the number. So when I see a number, I'm going to cross out and put x. The square of the sum of 6 and a number. So this is a little bit of a confusing translation. So whenever it's confusing and I see lots of ofs, I like to start closest to the variable. So I start closest to the variable. So I have 6, I have sum, and then I have squared. So for this, let's start next to the variable. It says 6 and a number. It says sum of 6 and a number. So the first thing I'm going to do is add 6 and x. So I'm going to do 6 plus x. And that's everything that happens close to the variable. I always like to start close to the variable. What do I do with the sum of 6 and x? What do I do with 6 plus x? Well, it says square the sum. Square the sum. So I have the sum, I have the adding, and then it says to square it. And that is the expression. I did everything in the English sentence and I translated it to math. Now, next part is this linear or nonlinear. Well, you should be able to see right away that it is nonlinear because this is squared. And when the x is going to be squared. Because the x is in the parentheses, it is going to be squared. And squared means nonlinear because that's a 2. And linear expressions, the variables, can only have 0 and 1. So it is nonlinear. Last one we're going to do before I take a little bit of a break to drink some water and rest my voice for a minute. Number 6. The cube of a positive number divided by the square of the same positive number. Okay, lots of ofs in there. We see 2 ofs. So this is going to be a little bit of a ordeal. But first, let's find what x is going to be. X, again, is going to be the number. How about we say, actually, we'll say x is going to be the positive number. So it says the cube of a positive number. So I'm going to cross out a positive number, and the positive number is going to be x. Over here, the same positive number, so I'm going to cross out the positive number again, and I said that's always going to be x. Okay, so now I have the cube of x divided by the square of x. Okay, so remember what I like to do. I like to start closest to the variables. Now we have 2 variables here, so let's do them separately. Now cubed, you should remember from module 1, means something to the 3rd power. And square means something to the 2nd power. So this says, this part right here, the cube of x. So this is going to be x cubed. And then we do the square of x. So we have x squared on that side of the sentence. So we did this part. We did this part. The part in the middle means divided. Divided by. So now I need to do the cube divided by the square. So I take these pieces and I divide them. So my expression is going to be that. That's my expression. The cube of x divided by the square of x. Now, part 2, we need to decide, is this linear or nonlinear? Now, some people are going to say, Mr. Bayer, this is nonlinear because we see a 3 and we see a 2. 3 and 2 are nonlinear, Mr. Bayer. You said because linear can only have 0 and 1. So this one is actually tricky. So some people are going to say it's nonlinear because there's 3 and 2. But those people are people who are not thinking about module 1. Because in module 1, what happened when we divided the same variable? What are our exponent rules we learned in module 1? Because let me stretch this out. We have x cubed divided by x squared. That turns into x times x times x in the numerator and x times x in the denominator. And already you've probably guessed what I'm going to do. X and x can cancel. X divided by x is 1. X divided by x is 1, which means this just turns into x by itself. 1 times 1 times x is x. So this is linear because it's just x by itself. The shortcut you might remember, when we have x cubed over x squared, your exponent rule for module 1, remember we just did x to the 3 minus the 2, which is x to the first. So this looks nonlinear. This looks nonlinear, just looking at it. It looks nonlinear. But if I graph this, if I graph it, it will make a straight line. It will be straight. So this is actually linear because it's a little bit tricky. Remember, linear just means it makes a straight line, and this one makes a straight line. It is tricky because it looks nonlinear, but it is linear after you use your exponent rules. So be on the lookout for some tricks on this. You're going to have to use what you learned in modules 1 and 2 also. Right now, I'm going to take a little bit of a water break, so now is a good time to pause your video, go back and check your answers to 1 through 6. If you have any questions, send me an email. If you feel good about this, maybe you pause the video and you try the next page. Try 7, 8, 9, 10, 11, and 12 before me, and then see if you can get them by yourself before I get them. But if you do not feel confident in working ahead, then just I'm going to pause my video. You can just keep going, and when I come back, we'll work on 7, 8, 9, 10, 11, and 12. Whatever works for you works for me. See you in a minute. Okay, I got my water. I got my voice rested a little bit, and I'm ready to keep going with number 7 through 12. Hopefully you are with me. If you're working a little bit faster than me, that's perfectly fine. You can check your answers with mine when I am done. But let's get going with number 7. Number 7 says the sum of 4 consecutive numbers. This is a throwback to lesson 1. Let's say x is going to be the first number. And in lesson 1, we talked about this a little bit. The 4 consecutive numbers. So if x is the first one, we need 4 of them. So x is the first. The next one is going to be x plus 1. Then after that, we get x plus 2. And then because we need 4 of them, we need 1 more, x plus 3. And that is how we use variables to write 4 consecutive numbers. 4 consecutive numbers looks just like that. Because if this is 1, 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4. 1, 2, 3, 4. It works for any number you start with. Whatever number you start with, you'll always get 4 numbers in a row if you do it like this. And now that's our 4 consecutive numbers. And we are doing the sum, which means to add them. So we're adding all 4 of these numbers. So that is our expression. Part 2 is this linear or nonlinear? Well, I see x's, but I see x's only by themselves, which means x by itself is x to the first. So our definition of linear says with the exponent of 1 with the variable, it's fine. This is linear. Some of you might be saying, Mr. Brother, what happens when we combine the x's? Does that change anything? Well, let me show you. If we do x plus 1 plus x plus 2 plus x plus 3, we have 4 x's. So this turns into 4x plus 6 when I combine my like terms. I put my like terms together. I have 4 x's, and 1 plus 2 plus 3 makes 6. Still, the x exponent did not change. This is still only x to the first power. So it is still linear. Nothing changed. I know number 6 might make you a little bit scared that things might change, but adding x's does not change the exponent. Adding x's does not change the exponent. Dividing, like we did in number 6, that makes the exponent change. but adding or subtracting will not. Let's move to number 8. Number 8 says 4 subtracted from the reciprocal of a number. Well, x is going to be a number. So I'm going to cross out a number and put x. It says 4 subtracted from the reciprocal of number. And remember what I like to do, I always like to start closest to the variable. So it says reciprocal of x. And remember, reciprocal means raised to the negative first power. So we say the reciprocal of x is x to the negative first. And it says 4 subtracted from the reciprocal. So where are we starting from? This is a lot of people are, here's a mistake a lot of people make. And I've been teaching for a while. Lots of people do this. They'll say this is it right there. X to the negative 1 minus 4. Because it's 4 subtracted from this. You know what? That is actually right. That is the right answer. Some people, I'm sorry, this is the right answer because 4 comes from the reciprocal. 4 comes from the reciprocal. The mistake people make is they just look at this English sentence in order. They think 4 subtracted, so they'll write this. They think this is the answer. That is not the answer. English does not, when you translate, you don't always just go in order. You have to think about what the words mean. If you ever translate from different languages, you know that the word order for different languages can change. So the word order is not as important as the meaning. The meaning is important, not necessarily the word order. So this is the right way. This is the wrong way. The 4 comes from the reciprocal. 4 from the reciprocal. That means we start from the reciprocal and the 4 comes away from it. Now so that's the expression. Now we need to decide, is this linear or nonlinear? Well, we have x to the negative 1. Negative 1 is not 0. Negative 1 is not 1. It's negative 1, so it's nonlinear. Remember, again, linear can only be 0 and 1. Negative 1 does not count. Okay, number 9. Half of the product of a number multiplied by itself 3 times. So again, tell me what x is going to be. X is going to be a number. So I have x is going to be a number. So I cross out a number, put x. And then half of the product of a number multiplied by itself 3 times. So product of a number multiplied by itself. That means I'm going to multiply x by itself 3 times. That means I'm going to do x times x times x. That is a product because I'm multiplying x by itself, x by x by x 3 times. That means x times x times x, and I'm multiplying. So that's the first part. I did all this, but then I take half of that. And you do half of the product. So I take the product and I divide by 2. I divide by 2. Now, that's the expression. You might be saying, Mr. Baylor, that is linear. I only see exponents of 1. It's x to the first times x to the first times x to the first. Except multiplying changes it. Multiplying changes the exponents. Because x times x times x is really x to the 3rd power. So this looks linear, but it's not. This is like the opposite of number 6. Number 6 looked nonlinear, but it was really linear. This one, when you just do this way, it looks linear, but when you do your exponent rules, it's really non-linear because we get a 3. Don't let these confuse you. Remember your exponent rules. I know it can be tricky. That's why we're practicing. More practice. Let's look at number 10. The sum that shows how many pages Maria read if she read 45 pages of a book yesterday and 2/3 of the remaining pages today. So to make this easier, X is going to be, what do we not know? We do not know the remaining pages. X is the remaining pages. So we take out remaining pages, and that's our X. And now remember, I always like to start closest to the variable. So we see 2/3 of the remaining pages. That means we have 2/3 times X. Of means multiply. 2/3 times X. That's how much she read today. Well, let's move away from the X. So we did the part closest. Let's move a little bit further away. 45 pages of a book yesterday. Well, 45 pages yesterday is just a constant. It is just 45. 2/3 of the X today, 45 constant from yesterday. And then what does it want me to do with the 2/3 X and the 45 constant? Well, it says it wants me to do the sum. So I need to add right there. 2/3 of the remaining pages plus 45 pages tells you how many pages she's read. That's the expression. So, and now this is a linear expression because the X is a, remember, the coefficient is 2/3, but the exponent is a 1. It's invisible because we do not have to write it. That was number 10. Moving on to number 11. Number 11 is like if you go to an arcade or some type of, maybe if you go to a fair or something, it says an admission fee of $10 plus an additional $2 per game. So I'm going to say X is the number of games. So the games is X. $2 per X. So we have an admission, so $2 per game. If you have $2 per game, that means it's $2 times how many games you played. So that's $2 times X. Because every time you play a game, you have to pay $2. So if you play one game, it's 2. You play 2 games, it's 4. But the admission fee is the constant. The admission fee is just what you pay to go in. So it's the admission fee plus the 2x. So it's the $10 plus the 2x. $10 to get in plus $2 for every game you play. That's our expression, and this is linear because the exponent is a 1. Even if we can't see the 1, we know it's there. Last exercise, number 12. 5 more than 4 times a number and then twice that sum. Okay, so X is going to be the number because that's what we don't know. We do not know the number, so X. And like I said, I always like to start closest to the X. So what's happening to the X? It's 4 times X. So it's 4X. And now we have 5 more than 4X and then twice the sum. Because it's and then are words that tell me that's the second step. So this is what I have to do first because we do it before the and then. So do this and then do that. So let's do this before we do that. 5 more than 4X. Well, 5 is 5 and more than means add. So 5 more than 4X sounds like it's 4X plus 5. 5 more than 4X. We did the first part. And then what do we do? Twice that sum. Twice means multiply by 2. So we do the sum, we do the adding times 2. That's our expression. 2 times the sum. 2 times 5 more than 4x. And this is also linear because the exponent is a 1 even if we don't write it. And multiplying by 2 changes the 4. It does not change the exponent. So we got a lot of linear on this page. Those are the exercises we've done. Hopefully you understood it all. If you did not understand it all, remember I am available for one-on-one meetings. I am available to help you. Just have to let me know, and I will help you as best as I can. There's also help in the pages for your problem set. You have the lesson summary right here that just summarizes everything we just did. The exit ticket is the last thing we're going to do, so let's slide that to the back. If you still need some help with these, they gave you 6 more examples on the homework helper from page 15. So on page 15, they give you the sentence, they tell you the answer, and they even show you what they were thinking, if it's linear or nonlinear. So use the homework helper if you still need a little bit more help. For practice, go to page 17, which is your problem set. And there are 15 questions on the problem set that you can work on. My answers to the problem set will be posted on the Google Classroom so that you can check your answers with mine to make sure you've mastered the skill of writing the expressions and then identifying the difference between linear and nonlinear. After you feel comfortable writing the expressions and after you know the difference between linear and nonlinear, then look at your exit ticket from page 13. And there are 3 questions on page 13, 3 sentences that you have to translate into an expression and tell me linear or non-linear. So my answers to the exit ticket are not on the Google Classroom, but that's why you practice the problem set first. And when you are ready, you do the exit ticket. You take a picture of page 13, and the picture is what you turn in on the Google Classroom. Again, if you have any questions today, you can re-watch this video, use the homework helper, or send me a message. Tell me you need some more help, and I will happily help you with however I can. Have a great rest of your day, and I'll see you for the next lesson.